go to Erick. Hello, everybody, and welcome to the week 6 of the Cassandra Cloud Native Workshop series. Welcome, everybody. Hello, Erick.
Hi, Bettina. Thank you. Thank you, everyone, for joining us again this week. I hope you're all going well. How are you, Bettina?
I'm very good. It's an overcast day here in England. I hope the sun shines on everybody else. And I'm really excited to welcome you today to this session. So.
Let's go.
And let's get started. Yeah, so we have our usual crew. So on screen, it's today myself and Bettina Swinnerton. I recently moved into this wonderful team of the DataStax developer advocates. And we have Erick RAMIREZ joining us from Australia, who is our wonderful Cassandra expert and the voice of the DataStax community. Thanks so much for being here, Erick.
Thank wonderful. You.
In the background,
nice to be here while in lockdown.
Oh gosh, yeah, for you. In the background, we've got Cedric, who's hosting for us today, and we've got Jack Fryer helping you with questions on YouTube. We might have a couple of other helpers from around the world who regularly join us, so everybody's on hand to help you with your questions. Okay. So, and let's see where we are in the series. So we've come quite a way, right? So in the first 2 weeks, we talked a lot about Cassandra and the fundamentals and how important data modeling is to running your application. We then progressed to weeks 3 and 4, where we did first basically implemented some basic CRUD, create, read, update, delete, and then moved full on to building REST API backends with a front-end UI. Then last week, we introduced to you the concepts of Kubernetes and containerization, and we demonstrated how Cassandra can run off the Cassandra operator. And so this week, we're starting to bring it together, right? So everything we've done so far, we're going to containerize our applications, and we will move them into the small Kubernetes cluster that we started with our Cassandra development last week, and bring it all together. We're going to run the UI in the Kubernetes cloud. We're going to run the backend, and we're going to write into the Cassandra cluster. So this will be, an important step towards getting your application out there and share it with others. And we're taking very small steps today, step by step, and show you how we've done this in detail. And we will be providing cloud instances like last week after the session. So we would like you to, pay attention, follow steps with us, see what we're doing, and then try it out on by yourself later on after the workshop. So that's the appeal, basically. Watch it. We will demo in great detail and then try it out yourself. Okay? Good. A bit of housekeeping. Yesterday, when we streamed, we had quite a few issues on YouTube. So if you have a problem with the stream not showing, or if you, so just refresh. That really helped a lot. But you can also go to the Twitch channel, which might perform better for you if you run into any issues. So we are streaming on both channels. If you have questions about materials and help, you can find everything on DataStax community. You can actually go down here to that link, the Cassandra Workshop materials, and everything is there, right? That also applies after the session if you have questions about the homework, or you need help getting along with these exercises or any other questions, please come and visit us on community, where Erick and myself and quite a few other people are very happy there to assist you, okay?
Yeah, and while we're on the subject, Bettina, I was just going to mention to everyone, so one of the most common questions that we kept getting from last week's exercises is the fact that people were having troubles running the exercise 5 in particular locally on their machine. The biggest problem that people have is they're running it on tiny machines. So if you only have 8 gigabytes of memory, and if you only have like two CPU cores, that's not enough. You're trying to run like a whole database, and then you're trying to run things like Prometheus, which are heavy software. You need at least 16 gigabytes of RAM on if you're running it on a laptop or your PC. Ideally, if you can have 32, that would be good. But yeah, so that's a critical point. People kept logging the same issues over and over, but it was because they didn't have enough memory.
Yeah, very good point. Thanks for bringing this up. I know that the definition of tiny machine might vary, but this is it needs memory to run this, and yeah, you might find it frustrating. However, last week we provisioned for a lot of nodes in Kubernetes with our cluster. So this week we scaled it down in our initial demo setup. So we hope that we'll have a better chance of following the exercises. And we are also not using quite as heavyweight pods this time. So we're not using the Prometheus and the Grafana. So we will have a better chance of running this definitely on a 16 gig of RAM machine. Okay. Some additional housekeeping today. I will be using Astra very briefly to just show you the connection to Astra. But otherwise, we won't be using Astra. And we also won't be using Gitpod today. So all the things that we install them locally and run it there. You can, however, open the Gitpod if you just want to see the whole code in your IDE. Okay. Okay, so we can move on to MENTI. Just see whether we can ask a few questions about where you're coming from, and I hand this over to Cedric to run the MENTI.
Yes, thank you. Hi everyone, I'm here behind the scene. So let's switch to MENTI. Can you give me a thumbs up telling me that you are ready and you can see me and hear me well?
All good for me.
So let's just bring up the code again.
Yes, so the code is 965769. Written below the video, but I will also put that on the YouTube chat. 5769. Here we go.
So again, try and do this on your phone, because if you're trying to do it following the stream is delayed. So do it on your phone.
Yes, exactly. So for now, it's plain questions. But when we switch to the quiz later on, because the faster you go, the more points you have, use your phone to avoid any delay and get the most points.
And somehow I've fallen off the screen and Eric is there double. But I hope I will be coming back after that.
Yeah, but each time you just speak, you just reappear. That's how that's a magic.
I don't know what's happening there.
Yeah, that's the magic of
okay,
Skype.
cool.
Not sure why. Try my best to fix that ongoing.
No worries. It's fine.
Okay, so question 1. Let's see. Before starting, yeah, nothing special about before starting. 3 small questions. And the first question is, what is your current progression in the series? So the 3 first questions are for people starting on July the 1st with us. Are you catching up? Are you still struggling with 1, 2, 3? We know that there are a lot of homework for weeks 1, 2, 3. And then 4, 5 are more hands-on. And if you just start later, tell us also and see if you are ready and if you manage to catch up as well.
Right, so there's a few that are still catching up. And particularly the ones who were really late in joining us, you're more than welcome to. That's not a problem at all. But check out the community.datastacks.com if you have any questions, and just scroll through the previous questions already asked, because it's more than likely that it's already been answered, and you can just follow the answers if you get stuck on something.
Exactly. Yeah.
But thanks for joining us late. I think that's still awesome.
There's no problem to joining late, and so most of people already have the same issues as you, and there are a lot of great resources on the community to get all the questions answered. Okay, cool. Question number 2 is back to what's your profile? What's profile describe you the best? And why put we this question is really we have some question from real beginners, and we also have some question for quite advanced people. And so the idea later would be to, if we do some series later during the year, maybe put some kind of visual code telling that this session should be for beginners and this session should be more for experts, or so which one are mostly dev oriented and other ops oriented, just because it's not easy to speak to a large audience with a lot of profiles and a different level of expertise. Managers, yeah, great.
Yoshi's comment and Craig's comment just made me smile.
Oh, Craig's, yeah.
I just have to say more too.
Yeah, okay, so yeah, each time just you jump in. All right. So, and last question, I will give you a bit time to answer all these, is what can we improve? Okay, we tend to try to improve each week, but yeah, we need your feedback.
Yeah, let us know what you think of and what we could do better, right? So.
Everything's perfect. More hands-on training. Yeah, so that's as well. So today is the second session we ask this question, and it's come back, yeah, hands-on. And so yeah, we have to find a proper balance with a lot of hands-on.
One of the, I think we got a couple of comments in the last couple of weeks where people talked about that we should speak slower. So we'll try to remember that.
Yeah, I hope it's okay today. So I know we're mixing also our different accents, but yeah, please let us know if we have problems with our speed.
With my accent, yeah, not the best.
Or with mine, or with Erick's. Everybody has one.
That's pretty hard to read all the comments, but we'll store them and we will use them in the next session. All right, that was the last question.
That was it?
Yes, I will put you, and now you are leading.
Cool.
See you later, folks. I disappear,
okay, perfect.
And now I'll go mute.
Okay, awesome. Right.
Thanks, Cedric.
So thanks very much, Cedric, for that. Yeah. Right, so this is what we're covering today. We're gonna go back a little bit and review how Docker works, and take some demos. Then we do the same for Kubernetes, review what we've done last week. Then we see how we are gonna build the containers. So we build the images and we build the containers and how to run them. And then we will be getting the app running in Kubernetes. And then it's just the typical resources, the hackathon that's coming up, and the homework, etc. Okay. Right. So I think a lot of you who did the first 2 weeks really had complaints about the virtual machines for our academy courses, and I think it was a good reminder how how big and fat virtual machines can be, because they basically package everything, right? So the entire operating system, and it makes them large and unwieldy. And containers bring an advantage over that they really only pack what is required into the container that is being packaged. So you could think of a container as a virtual machine itself, but that uses resources provided by the host operating system. And
I was just going to add the key for this slide, because I think a lot of people miss that, is that the difference between a VM and a Docker container is that in a VM, you have an operating system running inside that's part of the VM. So it's a complete OSI on its own, right? It's got a copy of the OS running within the VM. In Docker, it's completely just your application running. There is no operating system inside it. So that's a crucial difference. It's using the, using the operating system of the underlying host infrastructure.
Exactly. So this very large part here is no longer part in the containers. So they're much more lightweight. They're much more easily to be redistributed, and they assume, in the case of Docker containers, that you have a runtime that can support them, right? So you have a common runtime on all the different host platforms where you want to run this, and so you can just concentrate on packaging your dependencies and your application, which makes them a lot smaller and a lot more portable and shareable. And so there's basically two different things we want to consider. One is that we're building the image, right? We need an image, which is almost like a template of your application. And this includes everything. It's fully packaged. And we then use this image to instantiate the container or to run the container. So it's using an implementation of the template in order then to run the application. So we can create many containers based on an image. We can create them running at the same time. They're basically just programs that use the resources provided in the image. Okay. And I can show you that in a moment. There's some main commands. So Docker build, to build the image, to run. Docker PS is very good to see what is actually running on your system. Then you might want to stop containers. You can retag. We're actually using that to tag our images when we load them into kind. And one important thing and very convenient thing about Docker is that we can push images into online repositories, for example, Docker Hub, and we can pull them from online repositories, which is a feature that's actually very heavily used in Kubernetes, right? When we build our pods, we specify the image, and then it gets pulled from the online resource in most cases. So that makes it very easy to deploy on a different system, okay? And I think I can show you a few things about Docker. Let me just here. So this is, for example, I can run a simple, let me just go there, a simple Python 3 container, right? So this is basically under the hood, is calling an image, Python 3, which is coming from the Docker Hub. And now I have a shell, right? I have a shell where I can just run Python in. There you go. And then I can print hello. And I've got a full running Python application here. I can, for example, run pip and install, for example, the Cassandra driver. And then I just pull that off. It takes perhaps not such a good example because it takes a little bit of time to pull that. But now I'm done. So now I could actually run applications that contact my Cassandra database somewhere. But what I also want to show you is that, for example, I don't have an editor on this one, right? There's no editor installed. So it's a very, very basic image. It doesn't provide everything that I would explain, what I would expect from a full Linux operating system, for example, as it's installed by default. So it's a scaled down, very, very purpose-driven application, right? If I leave this, I can now look at my containers or my running containers, for example, with Docker PS, and currently nothing is running here. If I do a Docker PS all, I see everything that I've just run in the last few days before I basically actually pruned my system to not have such a huge list for you here. But you see here, this was the Python 3 that I ran just about a minute ago, and then it exited 15 seconds ago. And I can also look at my images that I have. I think it's ls. There you go. So you see all the tests that I've done in the last few days with Astra Backend, Astra UI, etc. The various images I built, and I could just run any of those now from this online.
Could you just make that a little bit? Can you just zoom in a little bit, Bettina?
Yeah, sure. And I make that a bit bigger. So this is here. Oh, it doesn't like that. I start a new one here. So is
and so while you're doing that, one of the good questions, Bettina, that Vijay asked was what? No, actually, it was Dheeraj Kumar. So what if the application is a different OS than the underlying host? I think that's a good one to cover.
Yeah, that's a good one. So the Docker runtime, as far as I understand, will provide you. So all the Docker containers actually are Linux containers that I have used, right? So the Docker runtime, even if you're running on Windows, the Docker runtime will provide you a Linux host, basically, in order to run your Docker containers. Would you say that's correct?
Yep. Which is why you can launch different shells and stuff.
Exactly. And I think especially for those who've been struggling with the VMs, right? It might be really worth investing more time in getting to know Docker and running it on your Windows machines, because it really opens up a huge amount of opportunities in running applications. If you have access to Linux basically on your machine, and Docker is a good way of doing that. So, for example, it allows you to run Cassandra in a Docker container, for example, and you can set up your Cassandra cluster with Docker Compose. They can run several instances, right? So it gives you it will give you a much better experience than working with the VMs. Okay. So how's the screen size now? Is that better, or do I need to make it a bit larger?
We'll see how we go.
Okay, perfect. Okay, good. I think so. I'll go back to the presentation. So and we come back to Docker and to the demos throughout, basically. So your application and containers, you want to be, you can pack everything in there. You can sort of say, which are the ports that I'm listening on, what are the environment variables that I need, that I expect, what scripts do I want to run, how do I want to use the storage and the disk, and how do I want to configure it, basically. So you can package this all and prescribe it very clearly in your container, so that your users don't have to make those decisions, and they don't have to install those requirements, and they don't have to set those variables themselves. So you basically can be very prescriptive how it runs. And for example, here, this is an example how this runs in Docker, right, for Cassandra. So, for example, you have the chance to define the Cassandra YAML environment variables directly by, when you run the Docker container. So you can override what has been decided by whoever packaged this together. You can decide what ports you want to export. This is actually a good command to remember, the -p, because it's basically implementing the port forwarding from your Docker container. So the Docker container runs on its own IP address in its own subnet for all the Docker containers. And you want to be able, if you want to interact with it, for example, if you want to redirect the UI to your browser, then you need to forward the ports, right? So, and this is, for example, how this is being done. And then you can define which volumes to use and where you want to store your data, etc. And in this case, for example, the Docker container is tagged with a tag. And so that's an easy way of getting, for example, a Cassandra Docker container up and running. Okay. Good. So that was quickly Docker. I hope, are there any questions on that, Eric, or can I move on to just reviewing Kubernetes?
I think we're good so far, yeah.
Perfect. Oh, perfect. Okay, cool. So yeah, I would like to use them. So put the comment into Discord. So good. Right now, Kubernetes, an open source system for automating deployment, scaling, and management of containerized applications. And for me, it's really sort of like it brings the distributed nature into this Docker world or into this container world. How do I manage resources running on several host machines? How can I tie them together? How can I, address them all from a single control plane? And how can I manage this complexity that I have there? And I think Kubernetes is a wonderful solution to manage this complexity. It's still perhaps not easy, right? Especially when you get started. It looks quite complex in itself. It can take some time to get configured and to get set up. But after a while, I think the benefits of the control mechanisms and the automation, I think they really outshine this. So I hope you will start practicing with it, start using it, because there's a lot of demand for knowledge and expertise with Kubernetes. And it's definitely something that is very promising. You can do lots of different things with Kubernetes. There's a couple of things that have been called out here. So, horizontal scaling is very often called out. It makes it very easy to scale your applications and, or for example, your database instances. Self-healing is another really important aspect. You can define states for your application. So you say, I need to always have 3 pods up, and Kubernetes will run this for you. So if one goes down, it will restart it, or it will spin up another one. The ability to roll out and to roll back. The service discovery, see what's actually in my network, and the load balancing. So there's a lot of different things that Kubernetes can handle for you, and all those things become more and more complex the more distributed your deployment gets. So again, I come back. I think it's a wonderful tool to help you with this orchestration of all these different resources in your distributed network.
And actually, when you were presenting last week, Bettina, a lot of I was fielding a lot of questions they were asking. So why should I be deploying Cassandra in Kubernetes, right? And it's all this stuff that we've got on the screen at the moment. The biggest things are it makes it easy to just scale out. So if you want to add another node, you just tell the operator and it will do it for you. the self-healing stuff that Bettina was talking about. So if an instance crashes for whatever reason, Kubernetes will automatically provision a replacement node for you and reattach the volume so that you're back online, or the node is back online.
Exactly. So yeah, so I think there's plenty of there can be plenty of examples, but take it away. Initially, I think there's a learning curve to get started with, but it makes the management of your distributed resources a lot easier. Okay.
And there's a downside, right? So the downside of the operator is what it actually does. It's exactly that. It's an operator. It replaces human administrators. You know, with the Kubernetes operator, you know, it will do the upgrades. It will do, you know, adding nodes. You know, it will do things, respond to, you know, nodes crashing and stuff like that. You don't need a human to do it anymore. Exactly. Perfect. So it also obviously abstracts things from you. So, you know, so it's and some things that you might want to do might be abstracted away, right? So, you know, it's a trade-off. So it's something, if you really want to get into the weeds with it, then you might still want to do your own installation of a Cassandra cluster and really explore it. And good. So let's go there's
a
a
little
good
bit over
question from Vamsi, actually. Sorry, Bettina. Good question from Vamsi. Does DSC analytics work in Kubernetes? The answer is no, not yet, because Apache Spark, which is what DSC analytics is based on, isn't supported yet for Kubernetes. So, so no.
Yeah, good question. Thanks for catching that. Good. So the basic terminology, basically, so a Kubernetes cluster, which is really the umbrella term for the the distributed deployment that we're looking at. In every Kubernetes cluster, you have a master or a couple of masters, which is basically the control plane. From there, all the different worker nodes are being controlled and directed, pods are being scheduled, etc. So this is a typical setup of where you have one master and 3 worker nodes. In the exercises that we did last week on Kind, we set up 5 worker nodes. Today we're going to just have 1 to keep it a little bit more gentle for your own resources. But you can have lots of worker nodes, right? So it's but these are basically physical machines or physical instances. They would have their own external IP addresses, and
while you're on the subject, Bettina, so Anil's asked the question, can I use shared storage for Cassandra instances running in Kubernetes? And going back to your point, the worker nodes are should be independent nodes. Just for the purposes of the exercises, we're using a Kind cluster Kubernetes in Docker. It's not what you would deploy to production. It's just to make it easy for you to be able to learn Kubernetes. That's what it's designed for.
Exactly. Actually, please bear this in mind. So Kind is a development tool. Kind basically allows you to have distributed resources on a single machine, right? And so in this case, they share all the host resources that you have on that one machine. In reality, you would have dedicated worker nodes who have their own, they have their own place in the network, they have their own IP addresses, they have their own resources, they have their own disks. And how the Cassandra operator works at the moment is that it will require one worker node per Cassandra instance, right? So you cannot actually deploy more than one Cassandra instance onto the same worker node, right? Okay. So a little bit more into detail, what's actually happening on the control plane. What is the role of the master, basically? So the role of the master, for example, has a key value store, which is a single source of truth. which just holds, information about the cluster and the operation of the cluster. We have the scheduler. The scheduler is responsible for scheduling the pods to the worker nodes. And in most cases, the scheduler ignores the master node. So the master node will very rarely hold any pods that are relevant for your application. And that is by design. The scheduler ignores the master node. We have the controller manager, and we have the API server, basically from where we communicate to the worker nodes. And then on the nodes, on the worker nodes, we basically have agents. You have the kubelet, and that's something that you would, if you installed Kubernetes from scratch, you would need to install the kubelet onto every node. And we have the kube proxy, which is, for the Kubernetes network. And so this is allows you to communicate with the master node. And then we have all sorts of Kubernetes resources that we can deploy to the individual worker nodes, right? So pods, for example, or services, it's additional things, okay? And something that's worth pointing out is that Kubernetes establishes its own network, right? In the Kubernetes cluster, it's an internal network. Kubernetes actually uses plugins for the networking. You have a choice of plugins to use if you install it from scratch. For example, Flannel is a plugin that establishes the networking. You have a choice how you want to set the range of IP addresses that are available, the ISR range. But the important thing is this is an internal network, and it's actually not accessible from outside. So if you want to address your nodes from outside of the Kubernetes cluster, you need to establish services that route this traffic, right? So for example, node ports or ingresses that allow to communicate directly with the pods. Otherwise, that is an internal network by itself. And now to the organizational structure so we have basically, this is not dependent on any worker nodes or the master nodes. These are organizational concepts, how we want to organize our cluster. And one important aspect here is the namespace. So we say here that the use of namespaces is optional, or use of multiple namespaces is optional, but actually, in fact, we always have namespaces already in a default Kubernetes cluster. We have the default namespace, which is typically empty, right, when we get started. But you already have system namespaces where a lot of the system pods are running in order to really make this cluster operational. And then later we create our own namespaces in order to organize our pods and resources. And that's really what it is. It is an organizational structure. It allows you to group applications because you might end up with a lot of resources and pods running on, and you might not want to see them all the time when you want to sort of like get some insights. So using a namespace is almost like a folder, a directory where I just see what is relevant to that particular application. We're using the QUIZZ operator namespace. I think we used to hard code that into a QUIZZ operator in its first instantiation when it came out. You might be able to choose your own name for the namespace now, but we just stay with this today. Okay.
It's just so not to confuse all of you guys. So we're trying to be consistent with the stuff that we present to you, but things like the name of the namespace, we call it QUIZZ operator, but it can be anything you want. It's just a logical grouping of resources in a Kubernetes cluster. Exactly.
And you can create your own namespace, and in fact, we're going to do that later to group our own applications in that. And then, we have a very, we can limit our scope. We can just look at what is running for our application. Have we set up everything that we need? And so we have a much better, structured view of what's going on in our cluster. But important, there was a question yesterday, the namespace is not tied to a worker node, right? It's it is a concept that's tied to the cluster. It's something how we organize our cluster, and it's not tied to any of the physical machines. Then something that's really important, you don't always need a storage class in order to run your applications, but you'd probably do it in most cases. And especially, of course, if you want to run something like a database, right, where we heavily rely on storage. So we use in this case something called persistent volumes, so that we can actually keep our data. It's not just sort of like within the space of the pod. And this is administered by servicing persistent volume claims, right? So basically an application makes a claim for persistent volume, and the storage resource is provisioned by the administrator. And in order to do that, we need to have a storage class that defines the characteristics of this storage. And there can be many, right? We will use something like local storage, it's called Rancher, but there can be very different provisioners, and you might have to use different provisioners depending on the infrastructure that you're running on. For example, there are storage classes for Google Cloud or for AWS, etc. Do you have a question, Eric?
Yeah, I think it's just a good point to, Guy Colby's had the question, from their experience, they have a problem with provisioning. They don't think that the Kubernetes is production ready yet because of the volumes not being persistent. And so my response to that is, Astra, the database that you've been using all this time, that in the different weeks that we run the workshops, runs in a Kubernetes cluster, and it's in production.
Yes, and we have production users, right? Not just workshop attendees using Astra. It is a production ready database as a service, and it's using Kubernetes and the persistent volumes. Absolutely.
Shalini had the question, does having a master worker set up in Kubernetes make the master the single point of failure?
You can have more than one master, right? I think there are failover mechanisms for that. So yeah, but if you only have one master set up, that is a single point of failure. So the CAS operator, when we run the manifest, and you will see that a lot of things get installed, right? So the CAS operator itself actually runs as a pod in your CAS operator namespace, but it sets up a lot of additional services, etc., in order to support the running of the Cassandra resources and the creation of those Cassandra resources. And they could be, for example, secrets or services, roles, role bindings, etc. So all these kind of things that are needed in order to give you a good experience of working with the Cassandra cluster. So this is why it's sort of, we group it into this manifest. If you can go inside and read the manifest in more detail, as part of the manifest, we set up a custom resource, and the custom resource allows then the creation of Cassandra clusters and Cassandra data centers and the pods that run the individual Cassandra nodes within your cluster.
And for those who are confused, so the manifest is just the manifest, that YAML file that you use to create the operator. One of the kube control commands when you run a create, you give it the name of the manifest.yaml file. So exactly. That's what Bettina's talking about. Just looking at this slide, right? So one of the things, I guess, one of our failings that I see is that we've made it look simple, but people don't realize how complex, all the complex stuff that the operator is doing, which is why it's very resource intensive. So running it on a laptop with only 8 GB of RAM and only 2 cores, for example, it's just not enough. You will kill your laptop. There's not enough power in your laptop to do it.
Yes, absolutely. So I think, the manifest, it looks quite easy. We basically say apply this YAML, right? And we send down a huge YAML, and a lot of things get created. But as part of the creation, a lot of those services and pods, etc., they might have to pull additional resources and over, from a repository. For example, they have to pull the images for the operators, for the pods. And so even though it might look like that the YAML itself sort of was applied very quickly, it can still take quite significant time to sort of get all those pods up and running. And, that they pull their images, they go through the initialization phases. In the case of the Cassandra pods, they basically just also boot up before they can actually then be up and running. So this takes resources. It takes network bandwidth in order to pull the images. You need to be on the internet. You need to be connected, and then it takes actually also some time just to get the pods ready into a ready state. Okay, and we see this later again in the demos. Moving on from the CAS operator. So we've basically moved that here into the corner to make it a bit smaller. This is what we will be doing today, in addition to what we've done last week. So basically, we want to deploy our backend. We still call it Astra backend because that's what we did the last 3 weeks. And we have our Astra UI. We have the Astra backend serving on port 5000. And we have the Astra UI on port 3000. And we will set up a configuration map in order to configure those nodes or those pods, when we bring them up. And in order to keep it nice and visible, we're going to organize it into the My App namespace, so we don't get mixed up with all the stuff that the Cassandra operator installed for its own use, right? So this is what we are going to do today. And your full app, a production app or whatever, could take a lot of different shapes, right, on Kubernetes. Here's an example, for example. So in this example, we've taken the decision to group the UI and the backend together into the same pod, right? So the pod would run 2 containers, and we run them in a redundant setup, so we would have more than one pod. We probably would group them into what we call a replica set, so that the Kubernetes scheduler can manage the state of that, and we would group them into a deployment in order to make this a very clean and nice deployment on Kubernetes. Today, to keep it a little bit simple, we could also just use the UI pod and a backend pod to not even use the Cassandra database, right? We could just go and connect to Astra and use the the database as a service in the cloud. And that's something, for example, that you could do for your hackathon code, yeah? So where you just provide application code and application backend and UI, and you link to running, storing your data on the Astra database in the cloud. Another setup, which is what we're demoing today, is that we have the pod, the UI, and the application backend both running in pods in the Kubernetes cluster, and we're also using the Cassandra operator and a Cassandra cluster in Kubernetes, and we're going to write directly into the Cassandra cluster. And we will just be spinning up one Cassandra node, again, in order to keep it just kind of nice and small, so that you have a chance of running it on your laptop. In all cases, we'll still be using the browser, which is on the host. So we will actually traffic, so we can communicate with the UI, so we can give them, for example, the post request for our, launch the journey, send all the data off to Cassandra. Okay.
Just quickly, Bettina, I was just going to say, so Frank and Guy Colbis, we see your questions. Just a reminder to everyone that We will be hanging around after the workshop for another half an hour for anyone who wants to stay. And we'll hang around and answer all your questions that we haven't covered during the session.
Oh, yes. Yeah. We didn't say that in the beginning, did we?
No.
So we are available for just an Ask Me Anything session after this workshop today. So we're hanging on for another half hour, and we're seeing your questions from Discord and probably from the YouTube chat, and answer them on real time as much as we can. And just one thing to perhaps remember, whatever, I don't see the questions in real time that you have. So I see the questions a couple of seconds later because of the YouTube delay. So I'm actually very heavily relying also on Erick of relaying those questions. So yeah. Thank you very much.
And while we're on the questions, we keep getting asked about the vouchers. So the vouchers we're going to release them in week 8, mostly because the certification, you can't book any exams yet. The certifications isn't open yet. We're slowly opening it up. We've got a brand new certification platform from a different provider. It's no longer going to be Proctor.U. And that's the reason why we haven't really given out any vouchers. You can't do anything with it yet. So just hang tight. You're going to get it when you get it.
Yeah, hang tight. But it's wonderful that so many people want to do the exams. That's fantastic. Good call. Okay, so today I will be doing everything on my laptop. I'll show you everything there. After the workshop, you have a chance of getting another cloud instance, and Jack Fryer will be, I think there's a form available where it can be requested, and we're going to send it out in batches after the workshop. So bear with us. It takes a bit of a time until it gets to you. But then, please go ahead and use it and see whether you can replicate the exercises that we did. And locally, just to remember, we need to have Docker installed, like Docker Desktop or any other Docker runtime. We need to have some parts of Kubernetes installed. We need to have kube control in order to be able to interact with our cluster. We will be using Kind. Kind, as I said, is a development environment to enable you having a Kubernetes cluster of several nodes on your laptop, on your single machine. And then there's a lot of command line stuff here. And on the cloud environment, you will have Git installed, so you can pull all the code. I think Kubernetes will be installed, and all the kube control, Docker will be there, Kind will be there, and it's running on AWS. Okay. And because it's running on AWS, it's not free. It's free for you, but we can't keep them on forever, right? So we will have them for a few days, or I don't know exactly how long we have them, but we can't leave them on forever.
We're making a commitment that we'll keep them running until Sunday. So just so you understand, so here's the thing, right? So they're not free instances, we pay for them. And so like last week, we issued out 2,000 instances. So every hour, not every day, every hour we are spending thousands by giving you those instances that we have to pay AWS for. They're not free.
Yeah. Okay, well, use cautiously, but use them. So because I think they're a great opportunity. So thank you, DataStax. Cool. So let's get going. Start setting up some containers, start compile some code, and experiment with those things. And everything is on the GitHub. We've really taken great care today to hopefully make the GitHub README very instructive. So in terms of what steps you should be taking. And we go through them together, and hopefully when you run into any issues later, just let us know at what step it didn't work. So that will help us a lot when we troubleshoot what's going on. So for further motivation, before, what we did in week 4, this is what you had to do to actually run your application. Remember, we were in Git pod. We had to set an environment variable for the UI, and then we had to run the npm install. That can take some time, right? Because we're downloading quite a few of dependencies, and then we do an npm run start. Then we check the UI on the browser, and then we do the same for one of the backends. Please don't run both backends. You just run, but some people, like myself, they prefer Python. And some people, like Cedric and a lot of others that I know, they prefer Java. But today I will be demonstrating, I think, everything in Python. But we've got it in Java, and we are available to answer questions. But we only need one. But this is what you had to do. You had to clone the code. You had to install the dependencies, and then launch it. And I think there were quite a few jokes about installing the dependencies for Java, because Maven always downloads a lot of stuff in order to get running, and it just puts a lot of stuff onto the terminal window, and you think, when is this going to end? But eventually you get there. And we won't need to do this once we have our Docker containers built and we run them. So this is, hopefully you will appreciate the simplification that's coming out of that, and perhaps inspire you to share your application with other people, because we will be using Docker and later on Kubernetes, and it's a lot less work in order to provision your applications. Because we use Dockerfiles, and Dockerfiles basically they do the work for you in a way. So here's the examples of the Dockerfiles that we will be using for our applications today. And we go into the Python Dockerfile to just show you a little bit more in detail what's actually happening here. And my colleague broke it out into a lot of different steps. So the first step is that we start with a base image. So this is the same image, or almost the same image that I used earlier when I showed you the Python pod, the Python container that I used. So we're basically using the base image from the Docker Hub, which is Python, in this case with the tag for Alpine 3.7. I just had to choose something. I could have been 3.8, or I probably could have. So Alpine is a very, very low, small Linux distribution. Then we're copying basically the application into our working directory of our Docker image, right? So we copy everything. So this is why, be in the right directory. Someone was in the wrong directory yesterday, and sort of they built the wrong thing. But be in the right directory. We're copying everything to our new working directory here, and then we run the pip install of the requirements. So you can see here we actually need to define an external requirements text file, which basically has all the dependencies that we want to install. So, in our case, it's only Flask.
What's pip install, Bettina, for those who are not familiar with it?
Oh, sure. Pip install is basically the package management for Python, right? So you can, so pip manages the packages. And you can install any package. For example, if you want to install the Cassandra driver, you would go pip install Cassandra driver. It's a Python thing, right? So it's the package management for Python. And nowadays, you should really be using Python 3, because Python 2 is really on its last legs. But you can, if you have both installed, you might want to use pip 3 when you run install. But in this case, we're starting from Python 3, so we don't actually need to specify what we're using there. We're starting with Python 3, we're using basically a pip 3, and we install the requirements there. Okay. Actually, on the previous slide, here we did the installation Flask cores, Cassandra driver, and basically those three things would now be in the requirements text, just those three names, and pip picks from the requirements text and installs those dependencies. So when you run your container, or when you build your image, you will see this pip install. You will see it pulling those resources, right? You will see it's coming through in order to pull that into your image. And then we configure the ports, right? We say we're gonna in our application, we actually say we're gonna host or serve on port 5000, and now we're exposing the port. So this is so that we actually can get the traffic out of the container later. And then we give our image the command, what we want to do. And in this case, we're basically starting, Python, which is the command to start running a Python application, and this is the application getting started with Astra PY. Okay. Good. Then to build it, you can just build it. You build everything in the working directory, and it uses the Dockerfile. So your Dockerfile needs to be in your working directory, and the Dockerfile is a reserved name. It has to have that name. It's called Dockerfile, and it starts with an uppercase D, so there's no choice. You need to have that file in your working directory. It pulls the instructions out of the Dockerfile, and in our case, we want to actually tag it with a specific name. We want to give it a name Node UI, for example, and we want to tag it with something. It's not something that you need to do generally when you build Dockerfiles, but we need to do it in order to work with kind, because kind wants a tag in the image, and it's just one of the things we have to live with. And so, yeah, build it with a tag, and the import into kind will be much nicer. And then we can run our Dockerfile, so we can run our Docker image. So now we run it. We're choosing the image Node UI, my image, and we're giving our Docker container the name Node UI, for example. Okay, I've just told you this. Okay, so let's show a demo. How about that, and see how that works. Let's. I'm here in. Let's go back. And so here's my different getting started with Python, getting started with Astra UI.
Could you zoom in again, Bettina, please?
Oh, sure. Yeah, let's make it really big. How's that?
Yep, cool. While you're doing that, and Suman, I did see your question. So the question was, are there any documentation for Cassandra running on AWS using EKS? And the answer is, if it's not already out there, it's coming. Saravan and Chinnami has a blog post. If it's not already there, it's probably coming out next week. He's written a blog post about it on how it's done.
Okay, perfect. Good. So let me just find the README. So this is the README, and I just want to make sure I don't make any mistakes here while I'm demonstrating this to you. So I'm jumping about a little bit. Here is the Docker files that we will be using. So these are the instructions, and now how to build the Docker file. For example, let's start with the Astra backend in Python, and we just use this command here basically to build it. And there we go. So this is I'm in the, let me see the command. Yeah. So this basically uses the working directory from getting it started with Astra Python. It tags it, right? And then we Astra backend my image. So that was very quick because I had it's cached, right? Because I had built it before. It was on my machine. Actually, I could probably remove the image. I think I can do. Probably don't, because I don't want to move everything that I have on my machine at the moment. Yeah, but so you see, so it went to the Docker instructions from Python. We took that, you see, this step 2, step 3, everything that we had in the Docker file, and now we're exposing the port, and then we have the we're giving it the start command, right? But it's only built, nothing is running. So yes, I actually don't have anything running here. So if I want to now run it, we can test that out. You can just issue it with some environment variables that we want you to specify them, right? We want you to tell that it's use Astra in this case, later on we will be saying don't use Astra, so it will be false. We want to forward the ports from 5,000 to 5,000 so we can actually access it on our local host. Okay, let's go and take that and put that in here. So, right, okay, so those who have been going through the exercises in week 3 and 4, they should really be familiar to this output. This is the Flask app serving, and just ignore these warnings, etc. But the debug mode is on. So this is now we should be able to host this on. See whether I can actually get to my careful presentation here to a local host. There you go. It's very small, but it says, "Hi, I'm the Python backend API. Please connect me to Astra via UI." So we've taken the feedback from the last few weeks that before we didn't serve anything on this page. So we would always go, "Oh, document not found, 404, sorry about that." We just put that one line in there in order to make sure, yes, this is actually running and this is what I wanted to run. Okay. Good. So let's do the next one for the UI. So it's how do we look at this one? I think I just realized that I probably, yeah, no, that's fine. That's okay. So let's build the one for the UI here. Where's the UI building? The UI image. So I need a terminal. Just a bit large enough, I hope. And let's quickly go into this, into the there we are. And so we have our getting started with Astra UI folder here, and we're building the Astra UI image. Okay, so this is actually nicer because it's actually doing something, not just using a cached image. So you see here, it's actually taking a bit of time at the npm install because it's pulling stuff from the npm install there. So anybody who's gone through the exercises in week 4 will remember that step as well, right? So you had to do it in Git pod, you had to do it locally, you had to run npm install and pull all those dependencies. And it always feels
so if
like
you have a slow internet
downloading a lot.
yeah. If you have a slow internet connection, it will, it will affect the how long this thing takes.
Oh, what's happening here? So notice. Oh. No, that's fine. That's all fine. Actually, this is these are warnings, but what's the maximum call stack size exceeded? These warnings you can ignore, but this one is not good. I wonder what that might be. Now what that be?
Raju Sam, ask us after the workshop. Stay around after the workshop.
Maximum call stacks succeeded. I wonder what that might be. Oh, I don't like that. I don't want to go into debug mode when I'm presenting. So you would see some very stern faces. So let's see. I might have to make sure I'm operating from a fresh image. Oh, no. What's all that? Oh. npm app. That is annoying. I'm just seeing. I'm connected, of course, to the internet because I'm streaming out to you guys. Okay, I think I just pull this, make sure that I have the right. What's that? Make sure I have the right code here. Just a second. Because this is important. We want to be able to build the image Oh, actually, I probably can use the image that I have in my Docker. Let's have a look what I have in the image. So you actually have to Aster UI quite a lot. Here, this one from yesterday, Aster UI, I probably could just use this one. This is 24 hours ago. So I'm really sorry, guys, that I ran into this issue, but we should just be able to use this one here. Okay, so I check. I don't think it's a problem with the code. It seems to be something with the npm pull as we have. So we're going to use this one. Okay. So this is the Aster UI. Tag my image 24 hours ago. And you see, actually, it's quite a large image, right? So if you imagine you using other people's images and they're being called while you're provisioning your pods on Kubernetes, and they take some time. So that is why it's taking time to download something, right? So this is why it's taking time to instantiate your pods, because they can be really large images. Cool. So let's see whether the command to launch the image actually works here. So we want to use the image for the UI. In this case, so we want to redirect. Let me just make this a bit larger here. So we want to, again, give it the environment variable true. We want to use the backend API address. We had to provide that, remember, to the UI, and we want to forward the port from 3000 out of the container to 3000 on the local host so we can run it. Yeah, so good news, that image is still working. I will definitely look after the workshop why it wasn't compiling this time. I think it was a problem with npm. It could be that whatever I have defined in my current working directory has, I made some changes. I didn't do a fresh pull, work with a fresh pull of GitHub, and just build it up there. But this is the expected outcome. You should be seeing this, yeah?
Sorry, Bettina, Puneet wanted you to post the details of that when you eventually debug it, because Puneet thinks it's a good idea.
No, exactly. This is the beauty of demos, right? It's because, when you read a blog post, everything is like, oh, it's just easy, 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 easy. But when you actually do it yourself, personally, I learn a lot from people making mistakes, right? And just, and I see how they're solving the issue and how they're getting into and how they're taking the system apart. And I think, it's inconvenient, perhaps, for the presenter, but it's actually probably still giving you a good learning experience.
Actually, that's a very good point, right? So, when we answer questions, particularly me, so I'm going to do a confession here, right? So it's only between 500 of us, so that's okay. I don't always know the answers. And in fact, most of the time, I don't know the answers to the questions that you guys post, right? I have to figure this stuff out. So, and a lot of times, when people ask a question on community, they don't provide enough information for us to be able to make a meaningful assessment or, analysis of what the problem is. So a lot of times we have to guess, we have to try and replicate it. We have to figure out what did you do different to what's in the instructions so that we can help you solve
it. Exactly. So thanks for making that point, because actually, we often, especially with this workshop material, we're just one step ahead of you guys, right? We've just gone through this a few times to test this, and especially, I'm not a UI developer, so all the UI problems that you had, and with running them on Windows and different browsers, etc. And so we had to figure it out really as well. So thank you for staying with us and with your patience. But we're humans and we're learning with you. So this is the output that we want to see, right? So this is basically the React UI starting up. So we see serving at 3000, and then it compiles and creates the pages, and it's compiled successfully. So now we can go to our localhost. there we are. Wonderful. So, okay, so Eric, just to, I probably should, oh, perhaps Cedric, can you just take me off screen for mine, because I would like to show you the connection to Astra, but I admit that I did not clean away my connection confidential downloads directory, so I don't want to show that, but I populate that. So if you just, okay, perfect, thank you so much. And I just want to make sure, one step I forgot when I set this up. Yeah. Okay, good. I've got it, so I should be able to stream again. Thank you, guys. Yeah. So okay, let's test that connection. And so we have taken a bit of time, but no error so far. So that looks quite good. And yeah, test successful. That's awesome. You know, guys, there were a lot of questions about it, a lot of problems, frustrating problems with the cross-site scripting. So I'm using a plugin in Chrome, which is called QUIZZ Unblock, which helped me to overcome these issues. You know, just bear with us. It's a demo app, but actually, so, okay. So now we do launching from workshop. There we go, and the journey summary. Launch. Here we go. And launch it. Time for launch. And let's log into Astra. See whether I have that hopefully into Astra. This one. There we are. Have a quick look. As I said, it's an optional step. I just wanted to show you this is totally how you can build your application, right? We don't use Astra today. You don't have to, but you can go in and you can connect. I think it's really nice. This is you can use the free database that's there for you with your, and we can see whether I'm actually looking to it. So I'll just use the spacecraft journey catalog to change that, to check that. And it's done a lot of tests, as you see. So launching from workshop. There you go. It went in. Here we go. So this is recorded. And I should have probably tallied this up, but there we are. Okay. I hope that's convincing you that this is actually working. And we can switch those things off here. Okay, so let's go back to our, any questions? Otherwise I just continue. Perfect. Yeah, so if you make your own applications for the hackathon, perhaps that's the way how you could deploy them, actually use them in the data science Astra. Wouldn't that be awesome? Cool, let's go into Kubernetes and set it all up. So let's get the cluster up and running from last week, right? And so we're going to use kind again. I've got kind installed. I've got kubectl installed. What we need to do is we need to configure it with a configuration YAML for kind, right? So kind also uses YAML. Kubernetes uses YAML, but this is the configuration YAML for kind. And we're now going to use then, we need to tie the context of kubectl to this new cluster that we're creating, because kubectl is not part of kind. kubectl is its own client, client application. You can use it to control any Kubernetes cluster, but you need to tie it, so you need to establish the context. And then we go in and we create our namespaces, we create a storage class, we create everything that's required by the operator, and we're gonna create our Cassandra cluster. Okay, and we will end up with a structure like this, not quite as complex, but just with one Cassandra pod there. Okay, right, we've done that. So let's go into the there we are. Let's stop those. We don't need that anymore. And sorry, Cedric, you're in the background.
Yeah, I'm in God mode, all in the background.
What would we do without you? So that's very good. So, see how I think these terminals, they don't like it when I make them too big. So I'll just start a new one. Okay. A bit bigger. So big enough? I think that's probably better. Okay, so all the instructions are in the README, and I'm going to use that actually. And actually, we need to stop the container so they will continue to serve. So that's just before we do that, before we go further, let's just go back to that. So you see, we have our containers still running, and actually, it looks like my Control-C stopped the container for the Python backend, but not the container for the raster UI image. So if I want to do that, I take this container ID. So take a copy of that. Actually, this is perhaps worth mentioning. I don't name my containers generally. I just start them, I just run them, and then the name is just an AI choice out of, as far as I know, it's the name, it's just an adjective like beautiful or interesting, and then it's the name of a famous hacker. I think that's what I heard. So you will see these strange names, random names applied, because basically I don't name my containers, and naming is one of the hardest things in computer science. So I am not very creative. Stop. This container stopped. Docker PS. Nothing is running. Again, if you want to see everything that you've run in the past or since you last deleted things, you see that we had, this was the npm source that didn't quite work, and then the Python one that stopped. Okay, cool. Right, so let's clear this up and let's actually get into client. So client is running. There we are. Client is running, is in the path. We can see, have we got any clusters? No clusters found. Let's set it up. So where am I in this one? Okay, I want to go to the. We created new folder for you in the repository with all the files, with all the cube files. So you don't have to change directories. And it's in cube files. So let's go to the top and have a look what we have in here. So we have the kind config YAML, and we've numbered them. We really want to avoid any misunderstandings. Let's see whether we're successful with this. So first, we're going to run the kind config YAML. We can have a look at that. So basically, we are defining a kind type cluster. We're giving it an API server port. You can totally choose that, but I'm just taking the default here, or whatever has been put in here by Alex. And then we're defining two nodes. We're defining a control plane node, which is the master node, and we're defining a worker node. So we will have a 2-node cluster and with one worker node. So that's the, okay. Good. Let's see that I get the command absolutely right here from the.
And for those who were wondering, last week you had 5 worker nodes. So it was a bit more resource intensive than this week. So this week it should be easier to run this stuff. Yeah.
Just a tiny bit. So hopefully today you will get a better experience with that. Let's see where it's done. Sorry for the switching here. I thought I had sorted out, but not entirely. There you go. So kind create cluster. We give it a name, kind Cassandra, and we're giving it the config. There we go. And so see, we don't often see emojis on the command line terminal. It's, if you paste this like that into a community post, it won't post, right?
Like
Community
Frank did.
But
Frank discovered that for
known.
us.
It's not, yeah, it's a known problem. We talk with the provider, just don't use emojis. And we've not come across this because we don't see many emojis being posted from the command line. So yeah, so just bear with us. We're using a third-party provider there, and actually, I don't think we would do a better job if we did it ourselves. So it's, so. Okay, just taking a bit of time. This is a bit faster last time. These are actually good steps. These steps are very, very similar to what you would be doing on a non-kind Kubernetes cluster. And you see, for example, here, we're installing CNI. CNI is the networking for Kubernetes that we need to have in place. And for some reason, it's not part of Kubernetes itself. It uses these plugins to facilitate that, but it's an absolutely essential step, right? It's something that you have to do. And then the joining the worker nodes, this is also something that you do. And that's also probably interesting to know, what happens if you run out of worker nodes in your Kubernetes cluster and you want to scale the Kubernetes cluster itself, right? So you can join additional machines into your Kubernetes cluster as another worker node and continue to scale your applications from within the Kubernetes cluster. Okay, so now actually this is very good. I didn't see that before, so I can just use this one. Oh, it probably did it for me already, right? So because kubectl get nodes. There you are. We associated. This is my kind cluster. I have my master node, right? Master, and I have my Cassandra worker node. Oh, it's a worker node. It's just our cluster. It's called kind Cassandra. No, this is a plain Kubernetes worker nodes, and so far nothing is running on it. And I'll show you a little bit here. If I do kind get nodes -o wide, you can see that they have internal IP addresses. Yeah, do you see here? These have internal IP addresses. These are actually not accepted, right? So this is what this CNI solution sets up. We have internal IP addresses. What is unique to kind is that we don't have any external addresses, right? So my worker nodes actually they're not, because they're all running on the same localhost, right? So we don't have any external IP addresses. And so this can present some challenges if you want to communicate with your kind Kubernetes cluster from outside, right? Because we cannot really easily access the IP of a worker node and then forward from there into the Kubernetes cluster. But this is a kind issue in a way, right? And there are ways around it, but they might just be a little bit more complex. Okay. Good. So what's the next step? Let's have a look. So we want to, this was here. We want to create our namespace, and we want to create our storage classes. We want to install the operator, etc. Okay, perfect. Good. So let's do that. So again, let's get up here. So we have our files here. We can just use them. So we just go and apply the storage. So just first create a namespace. Okay. Create namespace. You have a lot of shortcuts, etc. You can NS, etc. But I just write it all out. Create namespace has operator. Yeah, it's created. We can check on that. kubectl get namespaces. There we are. We have actually quite a few already, right? So this is what I said. So typically we have a lot of. Currently, nothing is in a default namespace. Nothing is in the class operator namespace too. But if you now say, "Oh, what have I got running on my kube cluster?" Get pods. I say, "Oh, there's nothing running. No, these resources found." But later on, make sure that you always specify the namespace, or you might actually end up in the default namespace, and so there's nothing to see here. What's going on? Nothing is installed, right? So keep that in mind. Okay, so let's install the storage class kubectl apply -f to storage class. Oh, you know, I didn't use the namespace to do this now, but I don't think I need to, right? Because I think the storage class is actually namespace independent. We can find out. So -n. You see, it's unchanged, right? So we, in the instructions, we actually showed that you have to specify the namespace here, but it's actually something that is for the entire cluster. It's independent of the namespace, okay? So let's see, have a look at the namespaces, kubectl, have a look at the storage classes. And there we are, we have, there was a standard one, a default one, and in this case, they both use the same local provisioner, right? It's called rancher.io. And both actually set up in the same way. We're waiting for the first consumer before we bind. And this is how you would reclaim that storage with the delete policy and allow volume expansion set to false. So you can look. I don't know everything, really. Storage classes is something that I found quite hard to get started with. So I'm very happy to accept those defaults that my colleagues who created the QUIZZ operator gave us. So thank you. So, okay, storage class up. Now let's install the Cassandra operator. So again, this time we really want to be installing everything into the namespace QUIZZ operator. So we want to make sure we specify this and then apply -f. And we had the wonderful idea of naming them. So this is the third step. And apply should be used on resource creator. Oh, that's fine. I should probably use create. No, that's fine. Okay, so now we have the namespace QUIZZ operator has been configured. So additional things have been applied to the namespace, whatever. We've created service accounts, QUIZZ operator, a custom resource definition, and this is really important. This gives us the resource of Cassandra data centers, right? This is actually the most important bit of the Cassandra operator, and so this has been created. We have cluster roles, role binding, role access control, and services created. But this is one of the most important bits here. Okay. Now we can see what's actually going on. So kubectl -n operator get pods. There we are. We have a pod, and it's a QUIZZ operator, and it's up and running. This is what we want to see, right? We have ready state of 1 out of 1, which means the pod only has one container. Later on, when we create the Cassandra cluster, we will see that our Cassandra pods have 2 containers. And those people who had problems getting them up and running, they're aware of it, right? So we have the management API container. So they call it a sidecar container in the Cassandra class pods. That needs to come up, but the Cassandra pod itself, the Cassandra container, also needs to come up. So this is a single container pod, the QUIZZ operator. And it's only one pod, but lots of additional things that are running. So it has more than just one thing. Okay, so let's apply the. Let me just see whether I hope so.
Just while you're doing that, Bettina, so I've noticed that there's quite a lot of people that have joined us late. Thank you very much for joining us again this week. I think we've doubled since we last made this announcement, but straight after the workshop, we're going to do a quick 5-minute break, and then we'll hang around for another 30 minutes for those who want to stay on, and we'll answer any questions you have after the workshop. So we'll keep going for another 30 minutes for those who want to stay on.
Yeah, absolutely. Yeah, if you have questions and if you have, we will happily answer them if you can. So, and cool. So yeah, we're staying longer, and then of course, Eric and I, we just love our community portal. Just any questions that we don't get to today, put them into community. We are really watching it, and we really do our best to answer your questions there. So, and other people learn from your questions, right? So you're really doing everybody a service. Cool.
And you know,
So
you can
now,
love us back, right? So they can love us back by hitting the like button underneath.
yeah, like me, like us. That's lovely. This is my first time presenting on YouTube, and it's actually really quite fun. So there you go. And let's start the. So you see, this was a very quick create. You know, we applied the YAML. It's all fine. Created. But so if you actually want to go into see what's happening, it's in the oops. You see, it's not ready. It's not ready, right? It will take a bit of time to get ready. So and that's why we sort of say, hey, you can just use the same thing with a watch command.
Right. So, you know, you were talking about it earlier, Bettina, that so at the moment it's in the status, it says that, you know, it's ready 0 of 2. That's because there's 2 containers like you mentioned before. So the very first container that needs to start up is the management API container. And that's what actually controls Cassandra within that pod, within that STS0 pod. So once the management API container has completely initialized and started, it will show 1 of 2. So as you can see now on the screen, it's initializing. And then when the management API does come online, it will then kick off starting the second container, which is the actual Cassandra instance.
Okay, so
VJ asked the question: how do we define the number of containers in the startup? That's what's in the operator. The operator defines all the stuff that needs to happen, so that you don't have to. We're making it easy for you.
In this case. But if you wanted to group, for example, your UI and your backend together into the same pod, you would define the containers in your YAMLs, right? So in your pod YAML. So under the hood, the Cassandra operator is also just basically using YAMLs or the equivalent of YAML descriptions in order to create this pod. So this would have an entry for container 1, you know, called, I don't know, I think it's called management API, and then it has which image to pull, and then it has the second one for the Cassandra and which image to pull. So if you want to see what's going on and wondering whether this is actually not going correctly, right? You can Control-C out of the watch, and you can actually inspect your pod and see at what stage it is, right? So you can go to, so you can do kubectl describe. Describe is a really good command in Kubernetes, and you describe pod. This is the pod that we are looking at. And then again, we need to still give the namespace. Oh, and I think a lot of people had this sort of like readiness probe failed. It just means I'm not ready yet. You know, I'm not responding to probably probes from the management API with this checking, you know, are you up? Are you up, right? So, but this is these are the steps that took some time. You see, first it was pulling images. There you go. It was pulling images, 3 minutes. Then it pulled, then it created, pulled some more stuff, right? Whatever it pulled next, something with a different tag. The management API, there you go. And pulled and then started Cassandra, pulling image busybox. You see, there's quite a bit of pulling. Pulling means it's pulling images from an online repository. This is where your bandwidth is required. Okay. So let's see where we are now. It's all running. So let's get a better screen here. There we are. It's all up and running. It's operational. So yeah, so these are some tools, right? You can watch it, and if you find watching too boring, you can go into describe the pod, and even before the pod is up and running, you can see at what stage it is currently, right? So we saw that it was putting the images and then provisioning and then getting them up. Okay, good. Right, so we have a Cassandra cluster running. So, and it's actually so far I'm fine. My computer is actually not suffering too much at the moment. Cool. So the next step is we bring up our own UI, etc. So perhaps, Cedric, perhaps it's a good time to do MENTI, and then we can, in the meantime, I can copy the images over, and because they take a bit of time, and then we have them ready in the kind cluster. I just show you before we do that. I show you what we need to do in the instructions. So we've built the images, right? We're using the same Docker images that we used before for our test with Astra. And now we need to load those images into kind. And the reason why is because those images are not anywhere on a repository, right? So our pods need to find them. We can basically create a local repository in our Kubernetes cluster by copying them into the cluster. And so you can do this, for example, because you're not ready to release your app. You don't want other people to get their hands on it. It's for testing. It might not be fully functional, or you want to protect your ideas. So you can basically just copy your images into your Kubernetes cluster, and kind has a special command for that. It's kind load Docker image, etc. And while we're doing the MENTI, I will be doing that because it can take a few minutes. So especially the UI, you saw earlier the UI is 1.1 gigabyte image. That takes a bit of time. Okay. Cool. You happy to do the MENTI?
Yeah, totally fine. I just jump on the screen, and I do agree, kind load can take some time, so that's a good time to jump into MENTI. All right, so I taking over, and now I'm sharing my screen, and the MENTI is starting. So remember, the code for MENTI is on top of the screen. So let me put that on the YouTube chat as well. 965769. And again, some housekeeping. So please use your phone or the browser you are using to answer a question. You will get the question faster, and the faster you go, the more points you get. All right, so I will wait for you. I do have 60 people there.
We've got 500 on the stream, so I wonder how much we'll get on MENTI.
Yeah, so
today.
let's...
500? Oh my God,
yeah,
amazing.
500, great.
Oh,
yeah, let's see how many people join. 63? Oh, we can do better than that. 8.
And thanks to everyone who's hit the like button.
Yeah. And if you keep clicking on the like button, you see that it's keep showing some thumb up. Yeah, that's so much. All right, 75. Okay. So we have 5 questions today.
I think so. Yeah, I think we have
5 questions. So, oh, I think they are on the next already. Let me see. Sometimes I'm just waiting for thumb up, and why do I have... Okay, so you know what? Sometimes I need to do the hard refresh stuff. You should be there.
Warm up your fingers for the very first hitting the MENTI.
Okay, here they are, waiting for players. So it's not an issue. Some leaderboard was just put before the question. Okay, let's wait for 100 player. Okay, I just click enter and let's go. I will read the question as soon as they appear on my screen. That should be the fastest.
But make sure look at your mobile, because the stream is like 2 seconds late.
Make sure you beat me. I'm gonna play.
Oh, do you? Oh wow, now everybody wants to play.
I'm gonna try. I think the best I did for this was 75 or something.
You know, I
I'm very
did that a
slow.
couple of weeks ago. I was the one presenting with the the best bandwidth and everything, and I barely hit the first 10. Yeah, you guys are crazy. Okay, let's get rolling. Question number 1. How does Docker relate to Kubernetes? Docker use Kubernetes to start containers. Kubernetes use Docker image to provision the pod. We don't need Docker for Kubernetes. What is Kubernetes again? Yes, most of you get the correct answer. Kubernetes indeed use Docker images. All right, so let's see if I put some leatherboard. Now, if I do have a leatherboard before, maybe I miss one of those. Okay, the leatherboard is there for question 1, and I think Bhavana was the fastest? No, Gingy Boy leading. Okay, that was question 1. Next.
I'm not even on that screen.
Oh, I shuffled any question, any answer. In Kubernetes, we define environment variables in a JSON file. They are part of the Docker image, a config map. Why do I have to care about the environment anyway?
Can we make the questions easier next time?
Oh,
I only learned
Erick.
Kubernetes by doing the workshops.
Yeah, config map. You know, the first was a trap, the second was a trap, the third was a good answer.
Oh, I'm sorry. I didn't introduce the config map today on the slides first. I'm sorry. Yeah.
Yeah, that happened. Okay. Cassandra needs to win, right?
Oh, close.
Oh, Cassandra, you
Yeah.
go.
Eman Varma. All right. Next question.
I don't know how you guys do it. I'm not even
In
on the board.
Kubernetes, all my
Right.
Cassandra pods have different internal IPs. Oh, this time you show that. Have different external IP address. Have the same IP address. Are all Ps in the same pod. Yes. Good. Who was the fastest? Yeah, we still have the leaderboard. I simply have one more, I guess.
I don't know how you people do it.
I know. It's impressive.
Yeah. Where are you, Erick? I don't see you. What did you put as an alias?
I'm in 50th
Oh, okay,
place.
right.
I'm not gonna give you my name. It's embarrassing. I don't even make the leaderboard.
I tell you, I hit the wrong answer in the last question.
And you wrote the question. Oh, that's
I
funny, right?
Oh, yeah, I wrote the question.
Yeah. Too fast, you know. Read the question, Bettina, come on. Okay, next question. The cast operator is running as a service, running as a deployment, running in a pod, running away from here.
If I don't make the leaderboard, I'll run away from here.
Yeah. Don't look at YouTube chat because I just answered the question. I don't pay attention, but all right. Okay, most of you did it well. Yes, so a service is an abstraction of multiple pods, and here it's a pod. All right. Puni, oh.
Oh, better.
Eman Varma.
Oh wow, my first time to hit the leaderboard.
Oh, where are you? Lord of the Rings?
Have a guess.
Lord of the Rings. All right, good call. It was fourth question, I think. We have one more to go. The CAS operator stores the Cassandra user password in plain text in a certificate file encoded in a secret. We don't need a password. We saw that last week as well. Two. Yeah, encoded in a secret. Each time 60, 60, 60. Pretty consistent. All right. And okay. Two. Oh, Puni was again very fast.
Unbelievable.
Oh, so
amazing.
Varma was leading all the way. Congratulations, you deserve your swag. So
perfect. Yeah,
for the 3 leaders, please contact Jack Friars on Discord to get a swag box. And if you live in India, you would also have to provide an email telling that you are happy to get the swag and giving the ID to your copy ID to Jack. Otherwise, swag box are stuck at the borders. All right. So now I'm moving back to you, and I will disappear. And now I'll let you lead.
Thank you.
See you.
So make sure when you email Jack, you provide your full name and your full shipping address as well.
Yeah.
Congratulations. I sucked.
And for those who didn't come out on top because the questions were a little bit too hard, I apologize. But yeah, I just had to come up with some questions. And next time I'll do better. Right, so in the meantime, I've loaded those images into the K8s cluster. I've kept the output here, so you see what happened. And load Docker image as the UI and into my K8s Cassandra cluster. And then it says, okay, so you see it copies twice, right? It loads twice. It loads it to every node in there. It loads it to the K8s Cassandra worker node and also to the control plane node, even though we won't need it there, but we don't have this kind of granularity of expressing this kind. And it says, oh, it's not yet present on the node, so because we haven't loaded it before. And so this is why the UI takes especially a lot of time, because it basically copies twice or loads 1 gigabyte and more. And then the backend image for the Python is a lot smaller. That was faster, but same thing. Both worker nodes or both Kubernetes nodes now have a copy of this image, and we can instantiate our containers now on kind, right? Okay, so let's go to let's have a look at the steps that we need to do. Okay, so now actually we need to take a few steps in order to make sure we can populate our config map correctly. So both our containers require environment variables to run correctly. And we want to configure them for the correct environment. In this case, we want to write into Cassandra. We don't want to use Astra. So we let me just show you the config map. So the config map, we want to give a couple of environment variables. First, we want to give the base address for the UI. We give the data center. This is actually the Java app that uses this data center information. We tell it to use Astra Force. We are telling it to use the connection point of cluster 1 DC1 service. I'll show you that while we're using this in just a moment. We're telling it to use the key space killer video. We need to log in to we need to have the right credentials in order to write to our Cassandra cluster. And we're using the username, the cluster1 super user. This was set up by the Cassandra operator. And we need to specify the correct password. So this password will need to change, right? This is for my last test that I had here. In your case, it probably says, change me. Yeah, make absolutely sure you change it, because this password changes every time you run the Cassandra operator. This is a one-off, right? So we need to get that. We need to populate that correctly, and we will pull it out of the secret. So to do that, okay, all right. Oh, I'm sorry about that. Yeah, so let's. Yesterday we were too fast, so I'm obviously talking too much. But so let's have a look at the secret. So kubectl -n cass operator get secrets. So here we have our cluster one super user secret, and we want to look into this and pull out the password. So kubectl describe secret cluster one super user. Oh, is it to describe? I think, yeah, with the I think I get just the YAML. So I just get the YAML, get secret cluster one super user -n cass operator and -o there, that's my secret. And here we need to then decipher this one. So use this one. We don't need to do the username. The username stays the same. But we can use this one here. Where's it? Doesn't like me to do copy and paste here for some reason. I'll do that in just here then. Oh, I think it might be because of the terminal. There we are. Okay, so we just use this one. So this is going to cause some error here. Right, so let's look up the command, because I keep forgetting what that is, to pull it out. So you basically need to echo and then put that password in that you pulled out of the YAML and decode it with base 64. If you're using Mac, you need to use uppercase D, right? So let's do this one here. Put that in there, and then, because I get this wrong quite often, I just rather copy it from here.
Just while you're doing that, so just a reminder for everyone, if you want to stay, we're going to stay for another 30 minutes after the workshop. We're only a couple of minutes away. And if you want to stay after the workshop, we'll be here for another 30 minutes, and we'll answer questions that you have, any questions you have.
Yeah, thank you. I'm sorry, I didn't realize it was running so late. So, but we're almost there. So, okay, so we put the password in there that we just pulled out. So, and then we have, nice, put them in there. Okay, so this is done. Right, so now a few words about this contact point. I'll show you that in a moment. So if we get, have a look at the services, let's clear this up. Have a look at the services that the Cassandra operator set up for us. Services. There's a couple of useful services that the Cassandra operator set up for us. For example, one here is the seed service, which is probably uses to spin up new nodes, so they know where to get the seeds from and where to get the information from. We're going to use the cluster one DC service, which is a proxy for our contact points. So this is, and you can look at this, describe service, cluster one seed service, minus. And you see here, it resolves to the endpoints, to this endpoint of 10.244.1.4, which is actually the pod IP of our Cassandra node. But the service takes the abstracts this, right? Because every time we spin up a new pod, every time we spin up a new Cassandra pod, for example, if it crashes and we bring it back up, or we make a rolling restart or something like that, right? So the pod might change. The IP address might change of the pod, right? And if we hard-coded that IP address of the pod into our application, then as soon as this contact point goes away, we get a no host available error. So the cluster 1 DC1 service is there to shield us, so from this nature of changing, resources under the hood, and it basically abstracts us away and gives us a very generic name how we can address our pod. And in our file, we actually call it slightly different. We have the full DNS name of it here. So we have the name of the service, we have the name of the key space, and then the domain of the service is cluster local. And this is how we can address our pod. So this is quite important actually to remember that. So let's have it. I take out this password while I'm here because we want to actually go into our Cassandra node now, and we want to configure the cluster to be able to take writes, right? We haven't got any schema in there. We just started it up. We need to have the key space and we need to have the schema. So let's, in order to log into the node, we do kubectl exec -it for an interactive terminal, and make sure that I get this right. We have we can use the namespace, and then we define exactly the name of the pod, right? Cluster 1, DC1 default, and log into bin bash. So we have a bash. So let's do that. So -n as operator, cluster 1, DC1. I think I don't want to. I've got the password in my copy cache there, so I don't want to use that. So I'm not copying it. Sorry for that.
-s/0.
That's perfect. Wonderful. And then bin bash. So I'm in my node. This is my node. This is my Cassandra node, and it behaves hopefully how any other Cassandra node I'm logging in to behave. So I can do a node status in it, and it's up. Isn't that beautiful? There you go. And you see that's the address, that's the IP address, But again, we don't want to tie our application directly to that. We just want to tie it to the service. So that resolves under the hood to this right IP address. Now we need to start CQRSH, and we need to use the cluster 1 super user. Is that the name? For the user, and then we need to use this password that I decoded in order to get into CQRSH. There we are. That's wonderful. So, so I'm logged into, and currently there is no such thing as the killer video key space, and also not the required schema that we need to have. So we've copied that all out for you here, and I'm taking that just from here. I copy it in from the README, and I just paste that in here. And it's creating my key space and all my tables, and also my one user-defined type that I'm using in this one for the location. So let's have a look what we have. Describe, or we just use killer video. And tables. Yeah, that's all I need. So we have a lot less table than I had on Astra earlier, because now I'm only configured for the spacecraft application. And so we have everything in there. Cool. So we should be able to create our application and load our pods and write into this. Okay. So let's get out of here. So we exit out of CQSL, SH, we exit out of the pod. Clear the screen a little bit. Okay, so let's double check our config map is correct. So click the I on the config map. So we have false, right service, right password. We should be fine. Right key space. Okay, out of that. Okay, so let's apply the config map. So we want to have kubectl -n. Oh no, we want to have a new namespace. We want to create a namespace just for our application. So we call it my app. How about that? Create a namespace. We have my app. And now we create the config map in that namespace. So kubectl -n my app apply -f and the config map for 05. There is created. It's in there. And now we have a quick look at the UI YAML. 6, I think it's all 7. The UI YAML. So here we're defining it's a pod. We always have to tell what kind we're creating. We give it the metadata, a name Astra UI. We use container name Astra UI, image Astra UI, my image, right? And so this is what we're creating. And we're telling it, please use the environment defined in our config map of name env config. So that's the UI. Same for, or very similar for the backend. So here we're telling it again as a pod. Our metadata name is Astra backend. Our container we're naming Astra backend. We use the Astra backend my image. We're exposing ports. Actually, we also implicitly expose the port 3000 in the UI. We just don't have it in the YAML. Here we're exposing ports for both Java and the Python API. And then again, we take the environment from the config map. So let's get out of that and apply it. So let's do control, apply, and apply. Okay, that's the backend created. And apply the front end. There we are. Let's check on the pods. kubectl get pods -n my app. See the power of namespaces. There's nothing else in there. It's just what we created, the UI and the backend, right? Just to show you how confusing this would get if we get all namespaces. Look how much we have got running in there. So this is the reason why we want to have namespaces. It makes it much easier to control what we have. Okay, so they're up and running. So we should be able to access port 3000, but we can't, right? Because they're running locally on local port 5000 in my Kubernetes cluster. So we need to forward the ports. And this is a workaround. You know, this is for us for our demo. If we want to expose the traffic coming out of the Kubernetes, I think you need to really look into better solutions like ingress, node ports. There's a couple of different things that you can do. For today, for the purpose of this demo, we just use node ports. Okay, we just use port forwards. So we've got that here written down and just use this one. I just use different windows for that. I prefer that. So we just create a new one here. And it's a kube control. Let's make this a bit bigger. So this is forwarding the port. Let's see what we get. So we have here host. Oh, hi. Well, I could have been a bit more verbose here with what I'm serving, but basically, hi, connected to the local database. It's very small, probably hard to see, but yeah, I'm connected to the local database. I'll work on a better message there. And then do the same for the port 3000. Again, make this a bit bigger. And this is a kube control forward, so you want to be 3000 and we want to forward the UI. So just forwarding that. So off to localhost. There we are. And now we've taken out the connection dialog because we don't need it, because we don't have a secure bundle, right? We basically established this the credentials on if the backend is authorized, we can go in there basically. So let's launch a new journey. So this is from Kubernetes cluster into the local Cassandra database. Now let's go check it out. Oh, I probably should have kept my window open to make this a bit easier. Do I still have it here? Have it in my history. I can get into the... Yes, wonderful. I can get into the node now. There you go. And I probably still have it in my history here. And let's clear this up. Oh, wonderful. I don't need to look up this password again. Right, I'm in secure this age. So let's use the killer video. And select all from spacecraft, journey, catalog. There we are. You know, we've just written into this is from Kubernetes cluster. We've got our journey idea. It's we started our journey. Is that actually a correct date at 9/26/22? Yeah, UDT. And there we are. So we can also look whether any metrics went in. So we can just get all from, for example, pressure over time, limit 10. There we are. And that was it. So we've built our images, we loaded them into Kind, we created our parts, and we successfully established the connection to the database, and we wrote into the database. It's full up and running. There you go. Any questions?
So thanks, Bettina. So we're going to do a really, really quick break, maybe 2 or 3 minutes. Just come back and we'll be back for another half an hour. For those of you who are leaving us at this point, thanks very much again for joining us for another week at the workshop, and we'll see you next week. And for those who are staying, hanging around to ask us questions, here's the time for you to take a break. And I'll do the same.
Thank you, guys. And yeah, if you don't hang around, see you next week.
I found someone new now. I have more room, no more formats to chain me. On the same page, we are effortless, schemaless, living in the future, you and me, made for us, serverless, living in the future of the clouds. Been through a couple of shipwrecks, so glad it's over with my ex. But we stay afloat cause you're my index. Seeing clearly now, don't need Windex. Zooming in what's important, I don't need the context. I know less is more when you keep my data in check. Hey, I think you're the best for me. Hey, cause you help me see. Whoa, oh, cause you're my index. Whoa, oh, my data's in check. Whoa, oh, cause you're my index. Index, index. I found someone new now. I have more room, no more formats to chain me. On the same page, we are effortless, schemaless, living
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.
Right, thank you.
Yeah.
Thanks, Yoshi, too. We didn't mention Yoshi, so Yoshi's helping us out answering questions on Discord and the YouTube chat.
Thank you, Yoshi.
So first question, Akshay, we do have that song published. I haven't got the link handy, but we'll get it out. We'll publish it.
So what questions do we have? So I've not followed Discord at all. I just opened it up. So what questions are available? Did anything come through the Slack?
The cloud instances you'll get them in the next 2 hours. Cedric's going to launch them, and then we'll send out the details in the next 2 hours. We're a bit short-staffed today.
There's no questions.
I'm trying to remember. I'm trying to remember Frank's question because I didn't want to interrupt you because we were already running late. What was Frank's question?
I think it was something about the password decoding.
Yeah. So the password secret. Yeah.
Is this the plain text or encrypted version of the password? In the YAML, it's the encoded with base 64, right? So it's the the encrypted one in the YAML. So you need to take it out and decode it, and then put that. We need to use the decoded one in our CQLSH and also in the config map, right? Actually, that's a good point. We shouldn't really be putting passwords into config maps. Absolutely right. Yeah, this is the wrong place for passwords. Decoded passwords. This is basically so. We cut a corner there, right? Because we would have had to set up another secret for our app, right? So that, and then you would have taken the secret, the password from the secret, and the environment variables from the config map. But we wanted to keep it a little bit more manageable for today. Yeah. So in real life, please don't put your password into the config map because it's basically plain there. Good point. Actually, we cut a few more corners, right? So in your application, you would probably want to have a replica set, right? And you would group your application into a deployment, which sets up all those things. The deployment sets up the replica set, and the replica set, there you define how many of your pods need to be up at all times, and that allows the self-healing and the management of your always-on nature, right, for your Kubernetes. Again, there's only so much we can cover in 2 hours, and I've already run over with what we have. So it's we showed you a very simple example, right? This wouldn't be production ready. Okay.
We're just looking for the link to SoundCloud for the song too. So. And Guy Colbis, go on.
No, I'm just mumbling.
Yeah, Guy Colbis. So you asked about the storage. I don't have the exact details, but I believe Astra is deployed on Google Cloud, and I'm pretty sure we're using persistent disks on Google Cloud for Astra.
Yeah,
But
I think we probably need to come back to you on that if we have if we have that information, right? Mm-hmm.
Thanks, Frank. Mukesh, the exams are pretty much identical to the quizzes that's in the academy courses. So if you're able to answer all the quizzes in the academy courses and even the question formats, they're almost identical. Not the questions are not the same, but the format of the questions are the same. I don't know, Frank.
Thank
it's
you
a
so
bit
much
late in the
for
day
your
for me to
frank
understand
comment.
that, but thank you.
Yeah, same. Oh, it's lovely to receive such great comments. Wonderful. So, but the proof will be in the pudding, right? So I think we really want you to be able to recreate these exercises. So I've got a 16 gig laptop. So that was okay for me, right? So I hope that you can, with similar resource, you can get to a similar state. And I hope you really can get there. We've got Big Quake, can't get UI Docker image to build. You know, I think there's a problem with NPM today. So
I'm disappointed, Craig. You haven't commented about my my Tigers Vest yet.
Hey, Big Quake, we're gonna. Okay. I look into this after this workshop, but this is not building. Yeah, so
I get a sense that you haven't read the FAQs because I've covered that question about the vouchers. All right. So Amit's question is, does the coupon expire anytime? It does. If you already have a voucher that we've already given you, we're going to honor it and we're going to issue you a new one. And on the community.datastacks.com, there's a long list of FAQs in there about the certification process. Have a look at those because I've already answered those questions. You're going to get them sometime in the next, towards the end of August, in week 8. And the new certification, you no longer need to book them. In fact, when you log in and say, I want to get certified now, there are proctors available 24/7 that will do the exam right on the spot for you. But please read the FAQs. There's a reason why we do the FAQs. Maybe that should be the homework.
Yeah, that's Eric is putting a lot of work into these FAQs, so read them. Good. Any more questions? I see Big Quake is having problems with NPM. I had problems with NPM, which totally surprised me, right? Because I hadn't seen this issue before. I think there is more of for us out of control issue with NPM today. Hopefully it's temporarily, because otherwise there might be a lot of people affected. And that's a bit the downside of centralized package management. But yeah, so it's I think it's not anything to do with the code, but I will double check. I will double check that.
Craig, you haven't said anything about my Tigers Vest. What's going on? Yeah, Amit, you don't have to search for the FAQs. In fact, if you just go to community.datastacks.com, it's right there at the top. It's hard to ignore.
So Frank has a question about local cloud environments for teaching. It's expensive. AWS looks prohibitively expensive. That's true.
Yep. Google Cloud is a lot cheaper, I've found. So even though
I mean,
I don't pay for it, if I can run stuff on Google Cloud instead of AWS, I do, even though DataStax is paying for it, just because it's a lot cheaper.
So Jay has a question about where we should store secrets, if not in config map. So you would store it in a secret. And if I find some time over the next few days, I might just extend the app and store it separately, right? And test it out, make sure that everything works.
Frank, oh geez, that's a big question.
Yeah. But
I
the
learned a lot
question is
from your
fault
questions.
finding. Fault finding. Yeah. Yeah, so it's hard. It's really hard to get started with Kubernetes fault finding. And actually, one of my friends was a really good Kubernetes expert. He recommended to build a diagnostic pod that you deploy into your namespace. And so this is just, for example, a Linux pod that has, where you have curl installed, for example, so you can test out your connections from internal. So I was getting into real problems creating an ingress for a kind, right? And I was trying to figure out what was going wrong. And so I deployed such a pod into my namespace, just a basic Linux container. I installed curl, so I could then sort of like really troubleshoot the the networking and whether was I getting the right responses from my were my routes working correctly that I had set up. So I think that's a really good suggestion. So build the diagnostic pod so you can explore your Kubernetes cluster from inside.
Vikas, I wasn't joking when I said that I didn't know Kubernetes until I did the workshops. So I learned by doing the workshops and answering people's questions. So you and I are the same. You and I are learning at exactly the same time. So yeah.
And I'm
Jay
too. Yeah, so it's still all new. So.
And Jay, so the idea with the operator is that everything's pre-configured for you, right? So like I said before, the operator is replacing a human administrator. You use an operator because it does the installation of the pods for you. It does the configuration automatically. If a node dies, the operator will automatically recover for you. It was one of the slides that Bettina had before. If you want to scale, you just tell the operator, for example, if you started with 3 nodes, you tell the operator, hey, I want to resize my cluster, and you tell it, I want 6 nodes now, and again, it will automatically do it for you. That's why you use it. Yes, Amit, there's a different exam. So the admin is how to, install, build, configure Cassandra, and the developer is how you write applications for Cassandra.
I just want to also come back to Vika's questions about good resources to learn Kubernetes. So there is actually a Kubernetes playground that you can access. It runs on Katacoda, so you can play with that. So it depends on your learning style. I learn most by doing things hands-on, and I think this is wonderful to be able to play with something. So I would recommend this playground. The other strategy that I really recommend for learning more about Kubernetes is go and set up this Cassandra operator and go and set up a Cassandra cluster, and then go in and look at all the stuff that's been set up for you. Describe the pods, describe the services, start reading the YAMLs a little bit, try to understand, the structure of those resource definitions, and just start taking it apart. I think that's also a good exercise in order to understand what's going on. certainly to complement any theory. There's lots of books, etc. And then there's a lot of courses. For example, Kubernetes does similar things. They also do administrator exams and developer exams. And so there's a lot of online courses in order to prepare for those exams. So the administrator exam is harder than the developer exam. So if you really want to understand how to administer your Kubernetes cluster, I would probably recommend to take one of those, right?
I can't remember who asked it before. Maybe it was Mukesh. And I wanted to make a point about it too. So between the admin and the developer, so Mukesh, I think his question was, are there better prospects between becoming a Cassandra administrator or becoming a Cassandra developer? There's a benefit for both, but I think by showing you guys the Cassandra operator, I think you'll realize that there is no need for a Cassandra admin because the operator does it, right? You know, the CAS operator is a replacement for a human being doing the administration of Cassandra. So what does that mean? You've been replaced with the software if you're a Cassandra administrator, you know, in 6 months' time or 12 months' time, because there's no need for you anymore. So, you know, I think Cedric also answered the same question. Being a Cassandra developer is the future because you either use Cassandra as a service like DataStax Astra, or you deploy it in a Kubernetes cluster using the Cassandra operator. Amit, it feels to your question. So the question was, where can we see the old Cassandra certificates? It kind of tells me that you haven't checked your emails because the links to your certificates were sent in the last 24 hours so that you can get your old certificates. And again, Amit, you need to check the FAQs on the community.datastax.com. I've already answered that question. Frank, do a kind delete to start from scratch.
And also, if it doesn't, so Frank's questions are for everybody. Frank's question is about how do I clean up properly, and he's had some issues with you know, something was still hanging onto resources, causing his Ubuntu laptop to crash, which is not a nice thing. I agree. So first of all, clean up. The easiest way is just to delete your kind cluster to get rid of everything that's running in this Kubernetes cluster. You know, remove the port forwards that you had if they're still, you know, for some reason still listening and causing things to hang. And also, kind under the hood. I show you that actually here. Kind under the hood is actually using Docker, right? So if we do, if I clean this up here. If I do a Docker PS, you see here that I have actually 2 Docker containers running here for kind, right? So this is what's, so basically this is what kind does. My master node is running in a Docker container, and my Cassandra, my worker node is running in a Docker container. And so these were the 2 nodes it's spinning up. So if you still see something running there, you want to kill that. Right, so you just go take the container ID, stop it, right, and clean it up this way, and that should really remove all references to kind. Okay. Okay. Any more questions? Frank, I will probably, if I come to a good diagnostic part, just will require some research and work and consultation with people who know way more than me. But I will publish this, right, and see what makes sense to, for example, in my tests, I actually like, if I want to work with Cassandra, I really like to have a local Cassandra client running. So I like to use a Python pod to quickly spin up a Cassandra driver and write to the database and check out that it's working. So that would be part of my diagnostic pod, for example. And my diagnostic pod would have an editor, so it can actually write a few more things. And it would have, you know, as I said, curl in order to check the connections or what is being served, right? So, but I'm sure that, you know, we can come up with a few more things that are more useful.
Jay, I don't know what your question is. I'm not sure what you're asking. So yes, there are Kubernetes, in kind, there are worker nodes.
You can add more worker nodes. You can also in Kubernetes, you can add more worker nodes. I think Jay's question went on, what is the advantage of operators? Can we use Kubernetes without operators? Yes, absolutely. You can use Cassandra pods without operators, right? So we have plenty of DataStax customers who actually, or also Cassandra users who have used Kubernetes for years, right? So this is it doesn't need the Cassandra operator. This is a helper resource for you, right? It makes it much easier to configure and spin up your Cassandra cluster. You totally can do that without.
Yeah, so if you did the week 5 exercise, to begin with, you launched a 1-node cluster. And as part of the exercise, you had to resize and go to a 3-node cluster. But those are Cassandra nodes, not Kubernetes nodes, because those are different.
Yeah. So the operator allows you to easily scale up, right? Currently, the operator doesn't allow you to scale down. So that's something that I think is being added. So it's an easy way to scale up. The operator allows you a few things, right? So you can easily do a rolling restart, for example, of your different Cassandra nodes.
I think I understand. So yes, you can add more nodes without using the operator, but you have to manually download the software, you have to manually install it, you have to manually configure it, you doing it. But with the operator does it for you. You just tell it, you change the size parameter from 3 to 6, and the operator will do the downloading, the installing, the configuring for you. Does that answer the question?
I think Yoshi has provided a good answer there as well. It provides a good end state. I think that's a very good point,
right,
Yoshi. Thank you.
Of course, Frank, you can show anyone the workshop. You can let them sign on with the workshop. They can ask us questions on community.datastacks.com if they want to. I've never been to Marrakesh. I don't think it's going to happen in the next 5 years.
Oh my God, Eric, you're so pessimistic about this coronavirus. So
I'm in lockdown. We're in full lockdown.
You're terrible. Okay, so any more questions? I think we're coming to the end. Yeah.
Yep. Thanks,
so
everyone.
More questions to community. Give us a little bit of a break, So I think it will be 2 hours before I log into the community to answer more questions. But thank you all so much for your attention. I think it's an absolute delight to work with everybody in these workshops. That includes the absolutely fabulous DataStax team. It's fantastic. But also thank you for this incredibly receptive and wonderful audience that we have here. Thank you, guys.
Thank you for staying. Thank you. See you next week.